In this video, we're going to talk about functions. A function is a relation in which each element in the domain corresponds to exactly one value in the range. So let's look at this function z. Is z a function? Justify your position. Well, let's take a look at the domain. 3 is mapping to 2, and 3 is not mapping to anything else in the range. -2 is only mapping to 3 and nothing else. And 4 is only mapping to 3 in the range. So in this particular case, z is a function because every value in the domain maps to exactly one value in the range. Now, it's okay that -2 and 4 map to the same range value. That does not matter. Okay? Every single value in the domain maps to exactly one value in the range. Okay, let's take a look at the mapping now. Okay, so again, every single one of these names are only getting one specific grade. So in this case, this mapping is a function. So let's explain why now. Again, every single value in the domain maps to exactly one value in the range. Okay, let's take a look at the next example then. Is this table below a function? Well, the 1 maps to 3, but 1 also maps to 4. So this table is not a function since 1 in the domain maps to 3 and 4 in the range. Okay, so what I would like to do now is plot those 3 points from the previous example. Here's 1, 3, here is 1, 4, and here is 2, 0. Now remember, we said this was not a function because 1 maps to both 3 and 4 in the range. So that's these 2 points here. Well, what type of line actually can be connected between the two? Well, it's clear it can be a vertical line. So if I can draw a vertical line and it touches the graph more than once, then the relation is not a function. This is what is called the vertical line test. If a vertical line can be drawn so that it intersects the graph more than once, then the relation is not a function. Okay, determine if the relations are functions or not. So when we look at the circle, we can tell very quickly, here is a vertical line I can draw. Okay, so this is not a function because 0 maps to 4 and -4 in the range. And this vertical line shows me that 0 maps to 2 different values in the range. Okay, let's take a look at the other example. All right. So no matter how many vertical lines I draw, how many times am I touching the graph? Well, once. So this is a function. Every domain value maps to exactly one value in the range. And again, the vertical line test helps us to be able to determine if it is a function or not. Okay, so the other topic I want to talk about in this video is what is called function notation. So functions are often denoted as f, g, h, and so on. If f is a function, then for each value x in the domain, there is one corresponding value in the range f of x. So for an example, y equal to f of x means a function in terms of x, or we refer to it as f of x. Okay. So f of x is the range. The x inside here is what is referred to as the domain. Now, we talked about linear equations in 2 variables earlier in the course, y equal to 2x, where x would be the domain and y would be the range. Now, with function notation, instead of y, I could put it as f of x is equal to 2x, where x is the domain and f of x is the range value. Okay, so now let's evaluate the following. So if I have g of x is equal to x squared plus 2x, I want to know what g of -4 is. Now, what does that mean? when the domain is -4, what is the range value going to be? Okay, so let's write. So every time I see an x, I'm going to replace it with -4. Because I have two x values here, I'm going to use -4 twice. Now, the rest of this you're just simplifying. -4 squared is 16. 2 times a -4 is -8. And 16 minus 8 is 8. So, in other words, when the domain is -4, the range is 8. Okay, let's take a look at the next example. So now let's do g of 1/2. So g of 1/2 equals, again, every time I see an x, I'm going to replace it with 1/2. Okay, so simplify. 1/2 squared, that's 1/2 times 1/2, that's 1/4. Half of 2 is 1. 1 plus 1/4 is 1 1/4, which is the same thing as 5/4. So when the domain is 1/2, the range value is 5/4. I always like to write it as an ordered pair to show the relationship, but this is really all that you would need here, and this is all that you would need here. Okay, let's take a look at the next example. Not everything in the domain has to be a number. Here it's a monomial, but we're going to treat it the same way as if it would be a number. So, g of 5y is equal to, okay, so 5y squared is 5y times 5y. 5 times 5 is 25. Y times y is y squared. 2 times 5y is 10y. I don't need to do anything else here. Again, as an ordered pair, it would be 5y and 25y plus 10y. Oh, 25y squared and y squared there. Okay, one other example I want to take a look at is g of x plus h. Okay? So let's write this first. So this can be written as, okay, so x plus h times x plus h, I can FOIL that. That's x squared plus xh plus xh plus h squared, which is the same thing as x squared plus 2xh plus h squared. So I'll write that here. Here I'm just distributing, so that's plus 2x plus 2h. There are no like terms that I can combine at this particular stage, so I can't do anything further. As an ordered pair would be x plus h, comma 2 x squared plus 2xh plus h squared plus 2x plus 2h. Again, you don't need to write it as an ordered pair, but again, I like to show the relationship between the domain and the range for each of these.